if I have an equilateral triangle, that means that all three lengths of this triangle, this length, and this length, are all the same. And ignore this length for now. Okay, I also know that this length, this angle, and this angle are the same. It's an equilateral triangle. Okay, well, if the interior angles of a triangle equal 180 degrees, that means that these three angles equal 180 degrees. There's three of them. That means that each angle equals 60 degrees. So this is 60, this is 60, and this one is 60, right? Well, if I take this line here and I drop it down, if I split this angle into exactly, and I make it a 90-degree angle, it does two things. It makes each one of these now 30 degrees, and this one 30 degrees, and it splits this line segment exactly into two. This one is now two of what it was originally, right? So now this is exactly 1/2 of what it was initially. Okay, now that makes a 30, 60, 90 degree triangle times 2. I got 2 of them. Okay, now there's special characteristics of a 30, 60, 90 degree triangle. If I'm given a length of any one of these, I can use sine, cosine, tangent, and the relationships of those to figure out the corresponding lengths, or I can use the relationships of a special right triangle to determine that. So the relationships of that special right triangle are as follows. So I have a short length, I have my short length, right, and then I have a long length, and I have the hypotenuse of my 30, 60, 90 triangle. So there's my there's my right angle. That means that this is the hypotenuse. That means that this is the 30-degree angle. This is the 60-degree angle. This is the long leg. Okay, the relationship between the short leg and the long leg. Okay, so if I know that, if I know the short leg, I can multiply the short leg by the square root of 3, and I'll know the long leg. If I know the short leg, I can multiply that by 2. So it takes 2 times the short leg, and I know the hypotenuse. Okay, so going backwards, if I know the hypotenuse, I can take the hypotenuse and I can divide it by 2, and I'll know the short leg. If I want to figure out the long leg, right, I can take the short leg, I'm sorry. If I know the long leg, I can figure out the short leg by taking the long leg and divide it by the square root of 3. Well, that's tough to do, to divide by. Okay, so this equals the long leg times 1 over square root of 3. It's mathematically the same, right? This is equal to square root of 3 over 3. Okay, so I just take this down here and I dropped it down there. So if I know the long leg, all I have to do is multiply the long leg times the square root of 3 and divide that by 3. That is, I take that long leg value that I know, plop it into the square root of 3, multiply that, or plop it into this equation, and then I can figure out the short leg. Okay, so if you're given in this equation one of these lengths, and you got to figure out like the perimeter or whatever, you just use these relationships to figure that out, and just do some radical math and you'll be home free. Okay. So I'm given this right triangle, and it's asking me to find the value of the hypotenuse, and it tells me that this angle is 45 degrees, this angle is 45 degrees. Right. Problem is, it doesn't give me anything else except the points on this coordinate plane. Well, what do? I'm lost. I'm not given any other information. Well, that's not true. So it tells me the distance of this x direction, and it tells me the distance of this y direction. Well, if I drop down this, and I move over this, right, I made myself a little triangle, right? And then that triangle, I have a y direction, and I have an x direction. and then the z direction happens to be the hypotenuse of this right triangle that I just made. Right? My y direction is 2 units, 1, 2. Right? It goes from 3 to 1, right? So my y direction is 2. My x direction goes from 2 to 4. Right? So if I go from 2 to 4 here, that is negative 2 to 4 is 6. 1, 2, 3, 4, 5, 6. So this is 6. Now, if I could figure out a way to figure out the length of this hypotenuse with the 2 legs, I'd be home free, because this hypotenuse of this leg of this triangle that I just made is a leg of one of these triangles. And it turns out, well, if I do it over here too, right? Well, this is 2, and this is 1, 2, 3, 4, 5, 6 as well. Well, that's pretty convenient. Those are the same. Well, it would be, because it's a 45, 45, 90 triangle, and that's one of the conditions of a 45, 45, 90 triangle, and you'll see that here in a second. Okay, so, well, how do I figure out z? Well, my Pythagorean's theorem says that z equals the square root of x squared plus y squared. Technically, it's z squared equals x squared plus y squared. But this is how you solve for z. So z equals square root of 6 squared plus 4, or 2 squared. 2 squared. Clean that up. 2 squared. 2 squared. So z equals square root of 36 plus 4, so equals the square root of 40, which equals, I'm going to reduce that, that's, let's see, 8 times 5, right, and that goes into, that's 4 times 2 times 5, and so that 4 is that perfect root, so it's going to be 2 times the square root of 10, right, so this is 2 times the square root of 10, okay? Well, that's awesome. And I remember, so that means that this is also 2 times the square root of 10. And if I remember my right triangle stuff, right, I can remember that if I have a 45, 45, 45, 90 triangle, 90 triangle, right, this is 45, 45, and 90. My lengths of my legs are equal to each other, so L equals L, and my length of my hypotenuse is L times the square root of 2. Okay, so if I go the square root of 2, if I go my hypotenuse equals my leg times the square root of 2, then my hypotenuse equals my leg, which is 2 times the square root of 10 times the square root of 2. All right, so now I have the square root of 2 square root of 2 of 10 times the square root of 2. I multiply what is inside the radicals together to what is outside the radicals together. So, and that's what I get. So I get 2 times 1, right? So it's 2 times 2 times 10, right? So that's 20, right? So, well, is there a 4 inside of 20? Are there any perfect roots? Yeah, there is. There is a 2. Let me carry the 2 forward. That's 2, and then that's 4 times 5, right? So that 2 will come out, and then that'll be 2 times 2 square root of 5, and then that's going to be equals 4 square root of 5. So this is going to be 4 square root of 5. Okay, another way to do that is I have my z squared equals 2 square root of 10 squared plus 2 square root of 10 squared, right? So I know that this was a square root of 40. It goes all the way back to here. So this is going to be z equals 40 plus 40, square root of 80, square root of 80, right? And if I do the square root of 80, that breaks down into 4 times 10 is 40, oh, let me hold on. Let's see, 20 times 5 is 80, I believe. 20, no, let's see, that's 50, that's 5. Wait, 4 into there is 16. 16 times 5 is 80, yeah, so that's 16 times 5. There you go, 16 times 5, that 16 is going to come out, right? So it's going to be z equals 4 square root 5, okay? So two different ways to do that. This way uses the special right triangle. This way uses Pythagorean's theorem. Okay, hope that made sense. Okay, so there's an airplane coming in for approach into Jacksonville Airport. And they are, let's see, how do I want to do this? Yeah, airplane coming from Jacksonville Airport, and they from ground to the airport, like what their GPS says, like if they have, like it says like an overhead view, it says they are here and the airport is here. Like an overhead view, the distance they are from the airport is this long, okay? And that distance is, I don't know, let's see, 8 miles. 8 miles. All right. And they're coming in at an approach of, let's see, they're coming into land at an approach of, approach from ground, their distance to coming from ground. So their descent angle, their angle of descent is, we'll say 12 degrees. So they're coming in at a descent rate or descent angle of 12 degrees, right? As as from perspective of the airplane. Okay, and let's. What is the height of the airplane? So what height is the airplane? What is their height? What is the height? Or what is the, I guess height is the wrong one. What is the altitude? What is their altitude? What is their altitude? Altitude. Okay, so let's draw that. Let's draw that. Okay. So this, what is their altitude? In feet. In feet. In feet. Okay. Well, first, how many feet are in a mile? Well, let's take a look here. If I remember, there's 3,000. I'm trying to remember 3 feet in mile. Let's see, there's 3,000, no, 5,600 something. Pause this and look that up, hold on. 5,280 feet in 1 mile. In 1 mile, so 8 miles equals, 5,280 times 8 equals 42,240 feet. Okay, so let's see how high they are. Maybe my math, I just made these up, so it might be physically I'm too high to see feet. Okay, so let's see, their height is going to be this. Their angle is, here's their angle of descent. Here's their angle of descent. So their angle of descent is here. It's 12 degrees, so that means that this is 12 degrees. Okay, and their distance is 8 miles. Like their distance as seen on radar, right, is 8 miles away. So what is their height? What is their height? What is their height? What is their altitude? Okay, so well, let's figure that out. So this is theta, right? Their height, their altitude, ALT is opposite over adjacent. So we're using adjacent, and so this is the tangent, right? So I'm going to say the tangent of 12 equals altitude over distance, which is adjacent, ADJ. How do I know that's adjacent? Well, I go, that's hypotenuse. Go to my angle of concern, round it. I find myself at adjacent, and the other one's opposite. Okay, so my adjacent is 8. 8. So this guy gets moved over to here. So 8 times tangent of 12 equals that, right? So I'll type that in my calculator. 8 times, how did I operate this thing, times tangent of 12 equals 1.7. Cool. Okay, so what's the tangent of 12? Oh wait, yeah, 8. No, that's not 8. 8 is 8 miles. 1.7 miles equals 1.7 miles. 1.7 miles. So 1.7 miles times 5,280 feet per mile. Mile equals 1.7 times 5,280 equals 8,976 feet. Okay, so that is how you do that. Hopefully that works out for you guys. All right. All right, so here is a triangle generically listed with some givens I just made up. 90-degree angles, some line segments, and just a few angles, right? Lots of 90-degree triangles in here, right? Here's a 90-degree triangle, right? Here's another 90-degree triangle, right? Here's a 90-degree triangle, big one. Like this is a 90-degree triangle, that's a big one, right? So this is a 90-degree triangle right here. So identifying those 90-degree triangles is the first step in, realizing what's in here, right? So if you know this is a 90-degree triangle, this is 30, this one and this one add up to 90, or sorry, this is 70, and this one add up to 90, you know that this is 30, right? 90-degree triangle of this one, this is 30. This is 70. Right, here's a 90, this is so this is 38 right here, right? So 38 minus 90, 90 minus 38, 90 minus 38 equals, this is 52. This is 52. This whole thing here is got to be 180, so plus 50, plus 70, excuse me, plus 70 equals, I'm sorry, this should be 30, this should be 20. Can't add. 20, 20, 20. All right, so 70, 70 plus 52 equals 122 minus 180 equals 58 degrees. 58 degrees. Right, so That one could be whatever we want, if we even need it. Who knows if we need it? Okay, so if we wanted to figure out the length of this one, this is 7 plus 12 plus 14. All right, so the length of this length, this is 7 plus 12 plus 14. This is 33. Right, the length of this is 12. This is 26. 33. This is 19. This is 19. Okay, so those are those lengths. Okay, so if I want to figure out like this length here, this is the opposite. You can't see it. So this is the opposite over opposite, OPP, over hypotenuse. So that is the, let's see, the opposite, that's going to be the sine. So the sine of 20 equals, do I even know, I know that? Did I say that I know that I knew that one? I don't remember. I'm going to erase it and say that I don't know it. Okay, so the opposite of the opposite of 20, this little line segment from here to here, this guy, the opposite of 20 equals, let's say x. X divided by 26. 26. So I'm going to take 26, put that there. So 20, so 26 times the sine of 20 equals, that's 8.9. So this is now 8.9. 8.9. Okay? So I'm going to erase this one. So if I wanted to figure out this one, this is also 20. Well, time's up. So this is how you kind of figure these things out. Use sine and cosine, and just, I'm going to pause it. Maybe we'll have some time later.